Addition or subtraction of vectors is done by adding, or subtracting, the corresponding components. Multiplying a vector by a scalar will change the magnitude of that vector. If vector u is a scalar multiple of vector v, then u is parallel to v. Or the converse. If vector u is parallel to vector v, then u and v are multiples of each other. In 3D, with the vectors a to b, and b to c. The vectors I, j, and k are special unit vectors that each run parallel to the x, y, and z axes. Every vector can be expressed in terms of the three unit vectors I, j, and k. It is easier to explain by using a diagram. Start with a straight line that shows the relative positions of the points. Now look at the ratio the line is divided into. Next, put in the total distance from A to B. Write this number below the line. And finally, write in the vector components, including the unknown one as x, y, and z. Reading directly from the diagram, we can see that point P is 3/5 of the way along the line AB. Written in vector notation, we have. Now it's just a case of applying the numbers we do know, and then sorting through the vector arithmetic. Not forgetting to give your final answer as coordinates. Both are given on the formula sheet. On the formula sheet you have the directions of the vectors is important. The dot product applies when both vectors are leaving from the same point, or when both vectors are going towards the same point. However, you need to be alert to the possibility of one vector leaving the point, and the other going towards it. In this case, you cannot use the acute angle between them. You have to extend one of the vectors so that they both leave from the same point. The theta you use in the formula is the obtuse angle, 180 degrees minus x. You're expected to know how to rearrange the dot product formula to find the angle. By using the rearranged formula, cos of theta will be a negative number. If two vectors are perpendicular, then the angle between them is 90 degrees, or pi over 2 radians. Since the cos of 90 degrees is 0, the dot product must equal 0. If two vectors, A and B, are perpendicular, then their dot product is 0. If the dot product is calculated to be 0, then you can say the two vectors are perpendicular.